Welcome to another episode of the Schlegel Design Remodel Podcast. I'm Amy Gerard, and today our guest is Jason Wright, who is the founder and owner of Jason Wright Electric, Kansas City area's premier electric provider for over 25 years. When it comes to solving electrical issues in your home, look no further than Jason Wright and his team. So welcome, Jason, to the podcast.
Wow, thanks so much for the great introduction, Amy.
Yeah, it's
I have
true.
a lot to live up to now.
I don't say false things, so. All right, so Jason, I'm going to ask a whole bunch of questions that I think homeowners have questions about regarding their electrical, because most people are probably like me and they don't know a lot about what's happening behind those switches and plugins. So
Gotcha.
We're going to start with, what is a short circuit? I hear that a lot. I don't really know what it means.
A short circuit is easy. It is electricity that is going to ground unintentionally. So it's basically electricity is going somewhere where it shouldn't. And it is causing enough current flow to shut off an overcurrent device somewhere. And that's a circuit breaker or fuse. Okay.
Okay.
So basically, if you take two wires that are not supposed to be touched together and touch them together, that's a short circuit. And it's going to spark and it's going to trip a circuit breaker.
Okay. So a ground is another wire that says go here. Is that right?
So in a normal 120 volt circuit, you've got three wires. And I'll simplify it. You got a hot wire that brings power to it. And then you have a white wire, and that is the return path to the source. So the black and the white wire is what makes the circuit go.
Okay.
Okay. Like a light bulb, it has to have power coming to it. And it also has a reference point pointing back to that source. So the light bulb knows that there's power there. Like you see birds sitting on the power lines outside and nothing happens to them.
Right.
Okay. Because there's no reference back to the ground. Technically, those birds, when they are sitting on those lines, they're electrified. Now, if that bird was able to touch that wire and the ground or a ground wire at the same time, they will get vaporized. Okay.
We have one really long leg.
Right. Exactly. Well, but as long as they don't touch anything else, they don't know that they're electrified because it doesn't have any reference. Okay. So that white wire is the reference point that points back to the earth ground or the transformer neutral. And that says, okay, this light bulb works because we have 120 volts difference of potential at that light bulb. Okay. I know that's a big word, but that just means at that light bulb, it sees there's 120 volts. So it's going to work. So the bare wire, because in a residential circuit, there's usually a black, a white, and a bare wire or a green wire. That bare green wire is just safety. That's all it is.
So it doesn't have to do anything?
It doesn't. You know what? It's just there in case something goes wrong. And its only job is to help trip the circuit breaker if there's a problem.
I learned a lot in that relationship.
I hope I broke it down enough. Sometimes it's hard to remember, hey, you don't have to talk tech, talk in language that people can understand.
Right. I feel like anytime we do something at our house, we YouTube it and I just know this wire and this wire, but I don't actually know what they mean, right?
Right. Yeah. You're going to have a black wire and a white wire, and those are the ones that make everything happen. And the ground wire is what protects you when something goes wrong.
Okay. I feel so enlightened. Next, a GFCI outlet. And do I need them in my home? And I think my home went overboard because every outlet is that. Is that right either?
Okay, well, so that's a loaded question. So yeah, a GFCI or a GFI or a GFCI do the same thing. It's just a GFI is a short term. It technically stands for a ground fault current interrupter. So they're easily defined by, most of them have a test and a reset button right on the face of them. And occasionally they will shut off.
They do. Yeah.
They do. A lot of things can cause them to trip. Sometimes problems cause them to trip, but otherwise close proximity lightning strikes will cause them to trip. Some system imbalance. I mean, there's just a bunch of things that will cause them. We call them ghost trips. They just trip because they're sensitive and they feel like something's going wrong, so they shut off.
Yeah, that's my
Okay.
house. Mhm.
Yeah, basically, you should have them anywhere you have electricity around water or electricity around grounded or stuff that's in contact with the earth. So good places for around your kitchen sink. They should be on your kitchen counter. They should be in your bathroom. They should be in your garage, because in your garage, you're standing on a concrete floor.
Okay.
They should be outside because you're standing in the dirt, in unfinished basements, because again, you're standing on the
Cement.
floor. So they're designed to shut off power before you can get electrocuted.
That's a good thing.
It's a fabulous thing. They are probably one of the biggest safety things that we've started using in electricity. And I want to say they came out in the early 70s, and they have really revolutionized and saved countless lives.
So I have a love-hate relationship because I know that sometimes they're probably doing what they're supposed to do, but it's annoying because then you have to hit the buttons. But I also do love that it doesn't do anything that I have to like go to the basement and hit my breaker box. Like it's right there and I just hit the buttons.
Right now, they actually make two different kinds of GFI protection. They make the outlets with the test reset button on them. They also make circuit breakers. So sometimes that GFI protection is in the panel. And so there are sometimes people have to go to the panel to redo that, to reset it.
Okay.
So now what we find a lot of people when they have that love-hate relationship where they trip them semi-occasionally is what they're using is going bad.
Oh, like
Okay.
your curling iron's going bad or your microwave's going bad.
You got it. Or the extension cord you're using to plug stuff in. Because what that's doing, it's looking at things in a very small level, and it's looking at a milliamp, which is a very small amount of electricity. What it's going to do when it sees electricity leaking, that gets to the threshold of, and it's between 4 and 6 milliamps, which is a really small amount, it's going to shut off power. So if you theoretically, if you took your curling iron and threw it in the bathroom sink, the GFI is going to shut off. If you don't have a GFI on it, you can take that same curling iron and throw it in the bathroom sink, and a normal circuit breaker will not trip.
I'm making the scary things.
Exactly. That's what I mean. They are an extremely good life-saving device. They're very reliable, but as any device, electrical device, when they start production of them, there are problems. And over time, the manufacturers resolve those problems. And it just takes evolutions.
I feel like this is jumping the gun on another question. Oh no, it's like two questions. So I feel like the reason that mine are always tripping is because my outlets aren't staying in. They start to fall out and then sometimes it'll trip it. Can you explain what that is and what should I be doing there?
Yeah, okay. That will cause that trip just because it's seen something funky when the plug's falling out. So that is, the outlet is worn out.
Okay.
Point blank. Inside those outlets, they have like a spring tensioner. So when you plug that blade in there, it actually grabs a hold of it, if you will. And over time, it just gets tired. And it just stops holding stuff the way it should. So, and you know, I will be honest, we have one of those in our kitchen that you plug stuff in and it falls out, right? So me being the electrician that I am, I spread the little prongs on the plug out a little bit. So it comes in at a little different of an angle. And that's just absolutely the worst thing to do.
Well, it makes me feel better about those of us that maybe are doing the same thing, that the experts are doing that.
Right now, I mean, it's one of those things because I mean, it's frustrating. You're like, crap, all I want to do is toast a piece of toast, right? And the thing won't stay plugged in. So you pry the little prongs apart a little bit and it stays in, then you'll think about it again. So it is one of those things that it's a simple repair. You just need to change out that outlet. Have your electrician change out.
I was saying, can you do it or can I do it as a homeowner or should I hire an electrician?
You know what? I would never recommend a homeowner does electrical work because there's some subtleties that can happen. And there's a lot of safety concerns because even though you go downstairs to the panel and shut off that breaker that's labeled living room, it doesn't necessarily mean it goes to everything in the living room. There could be 2 or 3 breakers that feed stuff in the living room. You know, there are people out there that have changed devices and they worked fine when they got done.
So the professional tip is hire a professional, but if you have some aptitude, you could maybe do that yourself.
You need to do it with a high level of prudence and care and safety.
Okay.
Okay. You know, because I don't want to be like, oh no, you need to hire an electrician, change that light bulb, right?
Right.
If you've got some mechanical aptitude, the skill set, you can probably change that device, but you need to make sure you know what you're doing and you're taking the appropriate safety precautions. Because unfortunately, yeah, electricity is not like water. When you don't get that plumbing fitting right, it drips, you know it. Sometimes electricity doesn't give you those signs.
We talked about when your plug won't stay in your outlet. What if your outlet plain old doesn't work?
That can be a lot of things. That can be anything from a loose connection on that outlet or a previous outlet that's on that circuit to a bad breaker to something going wrong in the panel. That's not something you can answer in a short answer. That can be a very simple thing to find, and it can be finding a needle in a haystack.
So basically you're hiring an electrician to search out what's going on.
You know what? Yeah, because my guys carry tracers with them so they can plug into an outlet that's not working and trace with a high level of accuracy where that wire goes from there. As a homeowner, if an outlet's dead, you know that wire goes somewhere else. So the problem could be with that outlet or where it goes before that. And sometimes finding that is, I mean, it can be a game. I've looked for stuff for hours before.
And then to fix it, you have to punch a hole in a wall, don't you?
Not necessarily. Sometimes you do. I would say probably 80–90% of the time you do not. But there are times that a wire will go bad inside the wall. And a lot of times it's from a external force. Somebody might have put siding on years before and drove a nail in it, or somebody put a screw in it, or, you know, and sometimes it takes a while for that to fail. So there are times that we do have to damage drywall in order to fix what we need to fix.
Which is why we're here.
Yeah, exactly. Exactly.
Okay, what is an arc fault? I guess I'm not even that familiar with this term. I've heard it though.
So an arc fault is kind of like the GFI, the ground fault. We have a new device that's called an arc fault current interrupter, or an AFCI. And it's believe it or not, there's a lot of technology crammed into this, right? So it is actually a circuit breaker, or they make outlets, but typically we use circuit breakers, that is monitoring that wire and looking for arcs or sparks, if you will. So there's a defined signature, if you will. When a spark or an arc occurs, it almost gives a defined pattern on that circuit. That breaker can sense it and it shuts off the circuit before there's enough current flow to create a fire.
So it's a monitor.
Okay, that's, you know, exactly. It is sitting there monitoring the circuit, looking for things that will cause fires. Okay. So, and there are times they are, as far as we're concerned, they're an extremely new, fragile, unstable, unpredictable technology. But they're code mandated, so we love them because we have to use them. But you know, Amy, it's like everything else. It's like the ground faults, the GFIs, when they first came out, they were unpredictable. They didn't think about things. Yeah. And it took over years to resolve some of the issues and help them get better. They're getting better. They're not quite there yet. So they are problematic, to say the least. But the intent of them is really good, because the intent of them is to help catch house fires before they start. They originally were only required in the bedrooms,
Oh,
which that honestly, that's where many house fires start to cause fatalities because people are sleeping. When you're awake and you see smoke, most people are smart enough to get out of the house. Now they've been expanded by the code to other areas of the house. And the technology is not there yet. Sometimes those breakers are still seeing things that are happening on the circuitry in appliances, and they think it's an arc and they're shutting the circuit
that's
off.
annoying.
It is annoying. There are some areas of the country that are starting to put restrictions on the arc faults on where they can go. Around here, it's a mixed bag. Kansas City still says only in the bedrooms. A lot of the other areas are saying we want them in. The current code edition says they should be in every room of the house except for the bathrooms and unfinished basements and garages. So pretty much any habitable room.
So when you say code required, does that mean I have to go do it right now? Or does that mean I'm grandfathered in until work's done on my house?
Yeah, you're grandfathered in until actual work happens in that area of the house.
Okay.
So the code actually is pretty clear on it. The code says that if you're not adding wire, if you're not adding more than 6 foot of wire to that circuit and a new device, like a new outlet or something, you're not required to arc fault that circuit.
Okay.
Okay. So now if you're going to have your house remodeled and you're changing out light fixtures, technically you're not required to arc fault protect that circuit. Now, if you're adding new light fixture locations or moving light fixture locations, then you are. So it's kind of one of those, we're still kind of feeling our way through it. And with codes, the local jurisdiction interprets them how they want to a lot of times. The code is the code, but there's some interpretation that goes into it as well.
Good to know. And I'm sure it's that way across a lot of different things. It's not just this one.
No, it is. And you know what? It's the same everywhere because everybody has what they feel like is more important than some other things. And when an inspector comes in to look at a job, they have a limited amount of time. So they're looking at a lot of stuff. And most of the time they have certain things that they will key on that is either personally important to them or to their boss, the building official. And the building official will be like, hey, this is what we want to focus on. We're going to make sure everything else, they're not going to let the building fall down around that item, right? And I think what their intent is, if they feel like if these certain items are taken care of, then everything else kind of falls around them. If that makes sense.
It does. Yeah.
An inspector can't literally look at every nail that's driven on a job or every wire nut that's put on a job so they're looking at the big picture.
Okay. Some more questions. Why do my lights flicker? What does that mean?
Oh my gosh. Yeah. So there's a couple or three different things we got to think about. Okay. Flickering lights just kind of blinking off and on rapidly. A lot of times that is, we have that issue with the new LED lights. Okay. That you're trying to dim and they're not designed to be dimmed, or there's an incompatibility issue between a dimmer and that LED bulb. That's a big issue. And it will continue to be a big issue because there's really no rules for the dimmers and there's no rules for the LED lamps or the diodes. So the LED manufacturers make something and it doesn't dim right. So the dimmer manufacturers tweak something so it'll dim it, and vice versa. They're getting closer. Neither will guarantee that their product will work with the other one. They will say that they tested it. And by testing it, they mean they hooked them up and they didn't look bad.
It worked.
Okay.
It came on.
And it worked, right? But even then, under some circumstances, an LED bulb will not dim with a dimmer. And not all LED bulbs are designed to be dimmable.
No,
they have to say dimmable on them, or you don't have a chance. They will flicker. Even with the dimmers, even if the dimmer and that LED bulb is working great together, because of their relationship, any type of voltage fluctuations coming in from the power company, you see more on that bulb. which is something we didn't have as bad, because your house, it will accept about a plus or minus 10% difference in electricity coming in. You can see it 2 or 3% with your naked eye. So you can see it a lot quicker than it's a problem.
Okay.
It's kind of a weird dynamic, but a lot of electrical stuff is designed for that. A lot of times when your major appliances start, your major appliances with motors in them, refrigerators, dishwashers, washing machines, air conditioners, a lot of times when those start, you will see a momentary dip in the level of light in your house. So that is normal.
Okay, that was a question I had.
That's a normal course of business. That is just saying that motor's starting and it's causing a slight dip in the voltage, and you're seeing that slight dip in the voltage. And once that motor gets turning, then it goes away, because it takes more power to get it started from a stationary position than it does to keep it moving.
Interesting.
It's like pushing a car. It takes more energy to get the car started. Once you get it rolling, it doesn't take as much energy to keep it rolling. One of the issues that I want to make sure everybody knows about is when the lights get brighter. There is some if for example in your house, when the refrigerator kicks on or you use the disposal, you see some lights get dimmer and some lights get brighter. That is a problem. And that is something that you should call the power company for, because most of the time that's an issue with the power coming in, and it's a real issue. It's not something that's inconsequential. It's something that should be addressed.
That's good to know. All right. Jason, how do you know when it's time to upgrade your electrical? My home was built in the 50s. I feel like there's some things still in the wall that are old. How do you know when it's time to upgrade that? And what does that mean?
That's a loaded question, because that can mean everything from the wiring in the wall to your electrical service and a lot of stuff in between. So first, there comes a point in time where the wiring in your wall is just worn out. It's worn out because it's old and the insulation on it gets brittle over time, and it loses its insulating properties. So there is still wire that was put in the 1910s that is still in service. I mean, you touch it and the insulation falls off of it. It's well past its life expectancy. Okay. They say 40 or 50 years wire's good for. The modern stuff may be better than that. There's a couple things to consider. In the late 60s, we started running that third ground wire, that bare wire. And before there, you only had 2 wires in your cables that are inside your walls, which makes everything work, but it doesn't give you all the safety components of it. So if you have a house that's built in the 50s, you probably still have the old 2-pronged outlets without the third ground hole on. And if you don't, you shouldn't, or you should, because that means somebody took out the old 2-pronged outlets and put in regular grounded outlets. And that could potentially pose some safety concerns under the right circumstances. Everything has to line up for it to be the safety concern. How's that? I don't want to scare anybody.
I know.
Okay?
I'm like, oh no, I have all those 3-pronged outlets in this 50s home.
So one of the ways you can put those in there is if you put ground fault protection on them.
Okay.
If you put a GFI on them, it actually makes it safe.
Okay, we're good then. We're good.
But if you said you got a lot of GFIs, then you're probably okay.
I do, like everyone.
So, okay. Oh, then you're fine. Then you're fine. That's actually a code acceptable way to do it.
Okay.
What we like to think about is a lot of areas in your house, you don't have 3-pronged plugs that you're going to plug in. Stop and think about in your bedroom. You plug in a table lamp that has 2 prongs on it. You plug in an alarm clock, 2 prongs if you still have an alarm clock, right? Most TVs don't require a ground for it. So if the insulation on the wire is not in bad shape, maybe upgrading the bedroom isn't as critical to you. So one thing to consider is in your house, if you put GFIs in, the surge strips or the power strips you plug in that have the surge protection are useless.
Oh.
They don't do anything. They give you more outlets, but they don't offer you any protection against surges. You have to have that physical third wire in order to help with that surges. So that's something to just keep in mind. When it comes to the breaker panel in the basement or in the garage or wherever it is, they do fail. They do go bad. And a lot of times they just go out of production and you can't get the parts for them. There is no rule of thumb. There is no code on when you should replace those. Many people recommend 30, 40 years, you should change them out. Even though there are no breaker spots left, doesn't necessarily mean the service is too small.
Okay. I'm listening really intently on this one.
It just means that you don't have enough spots to put breakers. Now, chances are if your service was put in the 50s and it's the original service, it needs to be upgraded because everything's old. And keep in mind, the parts of a breaker that actually protect you move. And they have grease on it to make sure they move. Well, after 60 years, that grease is hard as a rock and the breakers don't move. I was in a house this week actually doing a walkthrough with one of the designers that we work with a lot. And the customer wanted me to shut off their main breaker to see if their generator would fire, and the main would not shut off because it was bad.
Oh, that's so scary.
It is. They had no idea. They had no idea. Now, it wouldn't shut off just manually moving it. No telling if something happened where it needed to shut off because of an overload or a short circuit, whether it would or not. So that's the problem with stuff when it gets old. And there's no way to verify if this stuff actually works or not. There is no tester you can hook up in your panel in the basement to see if all your breakers are good.
Right. You just kind of have to change them out when it looks like it's time.
Right. And that's where there is no official guidance on when you should change them out. So it's like, how do you tell? Well, your panel's 50 years old, 60 years old, probably should be changed out. Well, who says? Well, logic. No.
It's electrical. I feel like that's logic.
Yeah, but so that's one of those things. Okay.
Luckily, my panel is newer. It's not 50 years old. So that's good. So Jason, smoke detectors and carbon dioxide detectors, is that something that should be replaced regularly? I know we talk a lot about replacing your batteries, but what do you suggest there?
It's actually better than what I suggest. It's what the National Fire Protection Association recommends. How's that?
That sounds really good.
So there's two different things. Carbon monoxide detectors, they're two totally different conversations. The carbon monoxide detector is basically looking for that odorless, colorless gas that will kill you. And it's produced anytime you burn fossil fuels with a lack of oxygen. And I don't want to go into the whole chemical cycle of how it produces it and stuff, but I could if you wanted me to. So my dad was an engineer.
You have so much knowledge.
Oh, no, he was actually an electrical engineer and a master electrician. So he taught me from an engine. He gave me the learning from an engineering standpoint. And so when I go to learn something, I'm almost driven to understand why it does it too.
Right. You can't just know this is how. It's, well, why do we do it that way?
Exactly. Yeah, it's like, so how does that work? So anyway, the carbon monoxide detectors need to be replaced every 5 years. The sensors in them fail. And the code requires those to be outside of every sleeping area. That is in the hallway outside of the bedrooms. If you have bedrooms on more than one floor, they need to be outside of each bedroom area. And then smoke alarms are required inside of sleeping areas and outside of sleeping areas. And they're required to be interconnected. Now, and this is like bringing everything up to current codes. The fact is if you don't have smoke alarms, go down to the hardware store, buy smoke alarms, put the dang things up. They save lives. So put them inside the bedrooms. That's the best place to put them. If that's all you're going to do. Now, what the code says is if there's smoke in the hallway and you have a smoke alarm out there and it goes off, it's really, studies have shown it will not wake you up in the bedroom. The ones outside should also be a combination smoke alarm, CO detector. And the code wants everything tied together. So if one goes off, everything goes off.
So do you do that in every remodel?
Yeah, you know what? That's a great question. A lot of that depends. The cities, again, drive that conversation. So the cities, a lot of the cities require this, and some cities don't. So the cities that don't, then it's an optional code upgrade. And the cities that do, it's a mandatory code upgrade.
We talked a lot about a lot of different areas of electrical, and I learned so much that I went off topic time and time again. So,
No,
Jason.
This is my passion, so I'm sure it's me more than you.
No, I loved this. I think people listening will love it, and it's valuable information that, again, some of us do know, but not all of us. So I think I'm excited for people to hear this.
Well, I hope somebody can find value in it, because for me, it was like, crap, I'm just talking about what I do, right? It's like you, when you're talking about marketing and all that stuff, it's like, I didn't have to study for this. It's not like I stayed awake late last night. It's just like, this is what I do.
Well, that's why I came to you. You're the expert. You know without having to research.